Hello, welcome back. So this problem is the 16th. I can't believe we're already in the 16th. This is the 16th problem of the regular season round of the MIT Integration Bee 2025 and is meant to be answered within 2 minutes. I suggest that you try this first before looking at my solution. But if you're ready, let's go look at my solution. So we're looking for the integral of sine squared of 2x times the exponential of 2x. Now, generally, whenever you see sine squared or cosine squared in the integral, it should already be like muscle memory to express this in terms of just sine or cosine by means of power reduction identities. Remember that sine squared of theta is equal to 1 minus cosine of 2 theta all over 2. If you're looking for the cosine in squared, instead, it's 1 plus cosine 2 theta all over 2. Okay? So the integral that we have is actually equal to 1 plus cosine 2 theta over 2. Actually, just x. This is x e to the 2x dx. We can split this. Let's factor out the 1/2 outside. 1/2 of 1 times e to the x, e to the 2x. So this is e to the 2x dx plus cosine 2x e to the 2x dx. Oops, 1/2. Okay, I hope that's clear. Now this one is, I think, pretty standard. This is a use substitution, e to the 2x over 2. Now this one is something we don't know yet, but is quite easy to evaluate. Well, not exactly very easy, but the method is very known, and that's integration by parts. So let's call this integral I. Let's call this I. So we have I equals the integral of cosine 2x e to the 2x dx. Now, if you have an integral like this one, it's automatic IBP, integration by parts. You can let, when it's exponential and cosine or sine, you can let u be either of them. In this case, I'd like to let u be the cosine. But before that, I'm so sorry, I made a mistake here. I did not see that it's 2x. So this should be 4x actually. This is 4x. Sorry, 4x. This is 4x. And this is 4x. Okay, so I let u be cosine of 4x. Cosine of 4x. So that the derivative is du is equal to negative sine of 4x times 4. So that's negative 4 sine of 4x dx. Then I'll let dv be e to the 2x dx. Similar to earlier, this is just e to the 2x over 2. By integration by parts, we know that this should be equal to u v minus v du, which is u. So that's cosine of 4x times e to the 2x over 2 minus 4 sine 4x times this one over 2. So I can take out the negative 4 over 2. So that's plus, minus, minus, 2 negatives, plus 4 over 2 times the integral of sine 4x e to the 2x dx. Right? So this time, we still don't know this antiderivative here, and we'll use another integration by parts. And this time, we let u, oops, why is some u? This is u equals sine 4x. The derivative of that is 4 cosine of 4x dx. dv equals e to the 2x dx again. v equals e to the 2x over 2. Okay, if we apply it here, so I must be equal to, let's write this again, e to the 2x cosine of 4x over 2 plus 4 over 2 is just 2, then sine 4x times e to the 2x over 2, so it's e to the 2x sine 4x over 2 minus 4 over 2, again I take that out, times the integral of cosine 4x e to the 2x dx. Lo and behold, this one is equal to our I. So this is just I. So we can write this as e to the 2x cosine 4x over 2 plus, I'll not cancel this out, so I can express later everything in terms of over 2. E to the 2x sine 4x and then this one is 2 times negative 4 over 2, so that's negative 4i. All right, I hope that's clear. So there's a 2 here. Sorry, there's a 2 here. Okay. So if you put this on the left side, we have 5i equals, I'll factor out the e to the 2x over 2 times e to the 2x cosine of 4x plus, oops, this is not here anymore, sine 4x, 2 sine 4x. All right. So we have our integral here for the I by dividing by 5. So if you divide both sides by 5, this becomes 10. Sorry, I just have to edit because I don't want to write again the whole thing. Okay? So, let's go back here. So now we have this as 1/2 times I is this one, e to the 2x over 10, times cosine of 4x plus 2 sine sine 4x. My handwriting is very bad, plus c. Okay? I think I did something wrong. Oh, this is something wrong. This should be minus. Minus. Okay? So the answer here is this thing. Okay, so let's tidy it up a bit because our teacher might give us point deduction if we don't. So where do I put it? I put it at the top. So what do I do? E to the 2x over 2 over 2, it's 4, minus 1/2 times 1 over 10, so that's 1 over 20 times e to the 2x times cosine of 4x plus 2 sine of 4x plus c. Okay. Technically, we still factor out the e to the 2x here, but I don't see much value doing it, so let's leave it as it is. Okay? So again, this is just using integration by parts twice to get the answer. I hope you learned something from me today. If you have any questions, clarifications, or any violent reactions, just let me know in the comments. Thank you for watching and see you on the next one. Bye-bye.